Hi, I'm Jack Carl, and this is my Week 2 presentation on my MATLAB composite body. I did a three-part body with the bottom shape being a frustrum, a section of a triangle pyramid, and the center section being a cylinder, and then the top section being a frustum, then reflected upside down, almost to take like a barbell shape. The first shape, the frustum, was definitely more difficult, and we've seen less examples of in class in the cases, so I'm going to walk through that a little more than the cylinder. For my frustum, I define the geometry on the left side as having a square base with length b, a height of h, and a top square with length a. That defines all the parameters of a square frustum. From that, I parametrize the frustum from the negative x1 and negative x2 plane, having at this bottom corner here. That's where v goes from 0 to 1 along the x2 plane towards the x2 direction, or positive x2 direction, and then u goes from 0 to 1 from negative x1 to positive x1 direction. And all of these go from 0 to 1 like a square shape. The important part of this shape, and in understanding how to parametrize x1 and x2, it comes from the triangle relationship on the side, where we see a simple triangle going up that diagonal curve. And there it's important to understand, especially that the plane system crosses the origin at the center of that bottom square. So when v is 0, it's at negative a over 2 or negative b over 2, and where at v equals 1, it's going to be at a over 2. So when v equals 0.5, it's got to equal 0. That parameter. So it's important to understand from the point where it becomes a square in the cross section to the corner is a triangle where it's following up that edge. And so these were really the parameters I looked at to understand the equation that I need to find. I said, hey, when w is equal to 0 and v is equal to 0, we're in that bottom left corner over here. And so we know that x1 is going to be whatever it is. This is looking at a section view through the x1 plane. It's going to be negative b over a over 2. And so this was just kind of the logic I used to help me figure out the equation that would solve all of these coordinates that it needed to hit. I then went through, and like last week's code, I defined the body just by its curves. I kind of grouped them by saying that I know all of these, that the height is definitely going to be constant. I know at all of these, the height is definitely going to be constant. These ones' height's going to be changing. So I just kind of went through curves. You set two parameters equal to a constant, and so these are each one of the lines what constants were set to what. Similarly with the surfaces, I went through and I defined the surfaces by holding one parameter constant like we discussed in class, and this is the code that I used for that. Similarly, I had a cylinder as my second body. That cylinder has a radius. I set the radius equal to a over 2, which makes the cylinder tangential to the square top of the frustum. It'll hit there, there, and there, so they just line up nicely like that. I use the same variable a in the code to just kind of run through both bodies. So I ended up setting length just equal to an arbitrary 10 in this problem. And then this is very similar to the case 2 code. You can see where, that should read theta is less than, or 0 is less than theta is less than 2 pi, 0 is less than radius is less than 1, and 0 is less than z is less than 1. That's incorrect, but the code reflects the correct parametrizing. I then went through and I did the curves like we've seen in class, where this one, the radius is equal to a constant and the height is equal to a constant. Here, same thing, but the height changes to 0. That's the relevant code. Same with the surfaces. Define the three surfaces. Here's what I held constant, and there's the code. For volume, I did hand calcs. I got the equation of a frustum online for volume. Same with a cylinder, but I knew that one. And I hand calced it to be 424.3. I went to the bottom of the code and I added a little bit so that I would return the value of each volume part as well, just so I could check through my math and make sure it was right. Got the same volume, so that was great. These were the plots that I had from my 3D composite body. I showed each of the planes in an isometric view. You can see here how the frustum was flipped. All I did is I just made b equal to a and a equal to b for this section, because I knew if I just swapped the top parameter to be equal to the bottom parameter, it would switch the shape. And so I lined it up like that. All right, thank you.